Good morning, everyone. Just want to make sure you had your coffee this morning, and that's all. Talking about data quality at 8:30 a.m. in the morning, how cool is that? Right? It's so cool. Without data, we are nothing. So thank you for attending our session today. I want to quickly introduce the team here. My name is Navneet. I am one of the leaders in healthcare life sciences. Me and my team, we work on data strategies for customers. With me on the stage, I have Shiv Narayan, who's our product manager for AWS Glue. And we're joined by one of our customer, Chief Technical Advisor for Vanguard, Andrew Rife. We're so excited to be here today to share some of our experiences, and then, of course, talk about some of the great things that we have. Thanks. So I'm going to start by talking about our agenda really quickly. So today, we're going to cover some of these topics. Before we actually talk about data quality, I want to spend a little bit of time why data quality is important. I'm sure if I say, raise your hands if you know what data quality is, everybody is going to do that. But more importantly, why that is important in today's architecture. How do you build data quality products, high quality data quality products, or data assets, if you will. We're going to give you an overview of some AWS services that supports data governance today. Why AWS data quality and other tools, and how the functionality features that we support. Then we're going to go deep dive in AWS Glue data quality. We're going to learn about some of the newest features that were just announced. And then finally, we're going to hear from Vanguard how they use AWS data quality for their data platforms. So I'm going to start with this slide, and this is the themes we hear from our customer. And if you look at some of these points on the slide, it's largely about that I want to focus on innovating the data, not on maintaining and administering a data lake. I don't want to focus on data quality as a consumer because I really want my data to be high quality products to begin with. And the reason I put this slide up there is because although it's not so much about the data quality, it is about data governance. It is about how you build a data platform, which is data quality is one of the components of that. Some example is my team needs to own data sets, pipeline, and repo that are isolated from other teams. The current data architecture is so slow, things like that. So I'm sure you can align with some of those themes that we have up there to really understand that how data quality and data governance is so critical. So I'm going to introduce you to this modern data approach that we have built for our customers. And this really talks about four main layers or 4 tiers. At the bottom of this tier of modern data approach, you have different storage. And I'm sure you have heard some of the keynote announcements yesterday. We're going to talk about some of them today. But how we are actually innovating in the storage, right? So when you talk about storage, we talk about how do you optimize cloud data stores on cloud, how you build purpose-built data stores, and how you scale it performance. And the reason storage is so important because all the quality rules you are building, you want to make sure that the compute for those quality is also optimized. And if your storage is not, then of course the quality rules are going to take a long time for them to be able to execute. On top of storage, we have data governance, and that's where most of your data quality rules definitions comes into play. The way we think about data governance is we think about 3 pillars. We call them understand, curate, and secure, or protect. Understand is all about how you actually, publishing your data in a catalog with the right quality information so that your consumers can come and discover those assets quickly. Protect is all about how you manage your data as storage and in transit, how you secure it, and then access to the data. And that's where a lot of data quality rules we're going to talk about will come in. And the curation, which is all about data management, data pipelines, transformation, MDM, and whatnot. So you have a storage. No matter what storage you choose, you need to have a data governance layer on top of it to build your data strategy. You may have heard of terms like data mesh, federated data architecture, and things like that. They're all kind of built on the same principle, which is actually aligned with FAIR, or the findable, accessible, interoperable, and reusable. When you govern your data, you put that layer. The next layer up is the act. This is where you start acting with the data, meaning that you're building your ML models, you're building your ETL pipelines, and things like that. As you can see, this slide is pretty much agnostic of what technology, what AWS services you are utilizing. It is pretty much talking about the best practices on how you actually build that up. And then, in the top layer, you have all these experiences, building dashboard, your GenAI agents, and so on and so forth. But the bottom layer is storage and governance, and that's where we're going to be focusing a lot on. Quickly want to take like a few minutes to talk about modern data governance on AWS. As we saw on that previous slide, at different tiers of storage, govern, act, and build and act, the central part of this whole data architecture is building a good governance model. And like I was mentioning earlier, that we have 3 main pillars: curate, understand, and protect. Manage, understand, and protect. And understand is all about the metadata, the listing, the catalog, the profiling, the quality information. Think about a consumer or an ML scientist or data scientist who's looking to build a business outcomes-based model, and they come to a catalog to find all of the data assets there, right? But when they find the data assets, how cool it would be if you display the quality information right there. And the quality meets 90%, they have more trust on the data that they have. So that all comes in the understand pillar. The manage pillar is all about how you actually execute those data rules, like data validations, data transformation. That's where we're going to be spending most of our session today. And then protection is all about storage, data at rest, data in transit, creating access policy, and so on and so forth. So I just want us all to think about that. As we think about data quality and implementation of data quality is part of a large ecosystem. And the large ecosystem is data governance. So some of the services that we have on AWS that you can utilize to build data governance on AWS, we have AWS Glue. This is a service that lets you create data catalog, technical data catalogs, ETL pipelines, as well as the data quality rules using AI and anomaly detection. We have AWS Lake Formation. This is a service that you can utilize to build fine-grained access to your data. So first, you have to make sure data is built, prepared, and ready for consumption with a high quality. Then you have to make sure that the data access is correct, and that's where you have AWS Lake Formation. You have Amazon SageMaker model for governance for ML. So the way we think about data governance is not only governance for data, but also governance for ML models, AI, no matter what type of asset you have. Most of you may be having assets which are not structured. They may be unstructured asset or semi-structured asset. The same rule kind of applies across the board. And then finally, Amazon Data Zone. I'm going to quickly touch on this service today. How many in the room have actually heard or used Amazon Data Zone last year? That's great. So Amazon Data Zone is a service that we have announced back in 2022. This is a service that can help you build your data catalogs, business catalog, metadata, as well as it integrates with AWS Glue on data quality, and for which we're going to give you a demo. So really quickly, Amazon Data Zone helps connect your producers and consumers of data. Consumers are the one who are actually using the data to build analysis. Producers are the one who are actually building the data product that consumers can utilize. Now, the good thing is about this architecture is that a producer can be a consumer, and consumer can also be a producer, right? So if I'm a consumer utilizing data, I can push data back into the catalog, and then that also becomes discoverable. One of the key theme of producer and consumer building data and exchanging the data information is that no matter how you're building your data, it has to be built with a high quality. If it is not, then you're going to spend a lot of time in going back and forth on building those rules for validations. But Amazon Data Zone is one-stop solution for you to build business metadata, to bring data products, to create a domain architecture, as well as integrate with AWS Glue on data quality information. How many of you have heard the announcement yesterday on SageMaker Unified Studio? Okay. So yesterday we have announced a new offering in Amazon SageMaker called Amazon SageMaker Data, AI, and Governance. I just want to quickly cover this really, really quickly. At the bottom of this diagram, you can see the most important components of data governance, right? So you can see data quality. We talked about that a bit. Data classification, data lineage, ML, guardrails, and all that, right? No matter where your data is located, it has to be governed, right? That's the first thing. And quality is one component of that governance. On top of data and governance, and data we also have now supporting SageMaker Lakehouse architecture that lets you kind of create a data architecture where you can easily have single copy of data, but you can also have Iceberg APIs to basically query the data using, whether it's data lake or data warehouse. On top of data and AI governance layer, we have a catalog. That catalog can help you list your data, your ML models, your Gen AI, and your compute. And on the top, we have this Unified Studio. The concept behind Unified Studio is a common portal where your data producers, data consumers, and data governance team can go. Producers can go there to build data using different tools that we offer and Amazon Q. Consumers can build their queries, their models, their Bedrock agents, again, using Amazon Q or manually. And then data governance team can come in here and they can set up all the domains, the quality rules, the data validations, things like that. It's a unified studio, can really help you build the architecture end to end. So now I'm going to change the gear a little bit, talk about data governance, then let's get back on the topic of data quality. So what are my motivation for building a good, high-quality data products? Because remember, as we discussed, all these data products are listing in our catalog that anyone can search and discover and see and request access to. So the more quality information you provide, the better it is. But some of the points that we have listed here, the first thing is that you can do improved decision-making if you have high-quality data products by providing the accurate and timely information. You can enhance operational efficiency. This is the topic where if you do not have a high-quality data product right from the beginning, more than likely the consumer is not going to like it. You're going to go back, build it again, fix the quality, come back again, and you're going to spend a lot of time in back and forth. So it'll help you to reduce the operational efficiencies that you might have. And then better user experience. Anything that has great quality always has great user experience, no matter what you're building. Data is only a product. There are other products, the physical products, the data products, the ML. No matter what product you build or utilize, having a good quality is going to give you a good user experience. So how do we do that on AWS today? Before we talk about that, what are the options that you currently have? There are 3 options that we have listed in a broad category. The first one is old guard quality tools. These are the tools which are traditionally built over the number of years of the shell product. They largely work with relational data sources. Not only, but largely work with relational data sources, right? Then you have the open source framework. This is great, but at the end of the day, you are the one maintaining that, the infrastructure. You're the one maintaining the updates and releases for your quality. And then finally, the niche solution. So you build something very custom for your need, which is great. And it solves your purpose, but it will not scale, right? As you bring other type of modality. I work in life sciences and healthcare, and a lot of times we work with data which are imaging, unstructured, semi-structured, and it keeps on changing. The modality is growing, the data is evolving. So you don't want to go with a solution that solves a specific problem, and then you start from scratch again if the data modality changes. So what we offer here is we offer AWS Glue data quality features and benefits. And so think about this, that we have a serverless, scalable, and high-performing platform using AWS Glue data quality that can help you build data quality rules without you having to worry about the infrastructure, without you having to worry about the compute and all that, and instead use a serverless architecture to build rules that can run over 100 million jobs for you in a month. And you get benefit from using open source framework like DQ through which you can build these rules. The second thing is that we also offer rules recommendation. Now, this is really important because you're going to see a demo of this in just a few minutes, is that when you're building data quality rules against an asset, right, you can start from scratch if you know the data really, really well, right? But how about if you do not have full understanding of the data, or if you want somebody else to recommend some rules to you? So we have this AI-powered recommendation engine that will inspect your data and is going to recommend rules to you. And then you can choose to modify it, remove it, add more. It's all up to you. We have built-in data quality rules and actions. So this can actually, you can build a pipeline if the rule fails, then we'll do what, and you can build all these actions as part of it. We are based on data quality definition language, or DQDL, which is an open source language that Shiv is going to talk more about, so that when you're authoring your rules, they're not getting authored in some, like, in an approach which is totally a black box for you. You want to make sure that your rules are open and you can easily share with other in your organization. And then the most important thing is that we support both data at rest and in transit. If you go back a few slides that I talked about storage and governance, like how they work together. When the data is in transit, it has to be secure and validated and have high quality. When the data is at store, it also needs to attain that same level of maturity. And then finally, some of the newest features we have around that is anomaly detection and data profiling that can help you build your quality rules with much more efficient way. So just finally, a few things before I hand it over to Shiv. One thing is that if you talk about a solution, a data strategy, where you are basically publishing your data assets in a catalog, and then that catalog shows a data asset, but with all the quality information. Now, the reason that is important is because you want to make sure your consumers can get all the information about the quality. How many columns were null? In my example, patient's first name is 70% filled, but 30% null. That may be okay, but at least getting that information out there for consumers to look at kind of give them a more confidence and trust on the data. So this is a simple pipeline. A data steward would come in, it select a data set in AWS Glue, And then they basically use the recommendation rule engine to get all the rules recommendation. And then the data quality is then going to execute these rules and show that in Amazon Data Zone. So really quick demo. In this demo, you're going to see that I'm going to go to AWS Glue. I have a database called Clinical DB. And within that, I have several tables. One of the tables is patients. I look at the patients table. It has number of columns, I think about 40 or 50. I go to this data quality tab within AWS Glue. And as you can see, I do not currently have any rules. I'm going to create a new data quality rules. And when I do that, I have two ways to do that. One is that I can order those rules myself based on those categories like uniqueness, completeness, and those things, and like column length. Or I can simply click this button called Recommend Rules. Right? When I say Recommend Rules, it's going to ask me for the IAM role that has access to the table in S3. My table is located in S3. And then I'm going to start this process of recommending rule. Now, this will run a job in the background, which is powered by our model, and it's basically looking at the entire patient's table and is going to recommend me certain rules. So the job has started. Once the job is finished, we're going to look at the rules that it actually has built. Like I said, you can still build the custom rules. So now my job is done. I'm going to look at the rules that it created. So I'm going to click this button. As you can see, there's a list of rules that it built for me for that specific table. Right? And you can see in this list, I have some categories like complete length, is complete, uniqueness, and all that. I'm going to say I'm going to take all of these rules. There are about 72 rules that it recommended for me. And I'm going to add that in this, right? And then if I want, I can take some out. I can add more and do whatever. This is a DQDL. And then it basically saves the rule. So I'm going to save my rule. I'm going to call it patients data quality rules. And then I'm going to save the rule set. And then I'm going to start running the rule set. What is happening in the background when I do that is that it's going to go and run all the rules against the entire table. It's going to check that which rule is passing and which rules are failing. So I'm going to start that run. I'm going to choose the IAM role. This is the same IAM role that I've chosen previously, and it's responsible. Basically, it has access to the data under the hood. So my rules are running. You can see there are 72 rules. There's a small text there that is recommended. Once the rules are done, we're going to go and inspect those rules that actually what has executed. So rules might completed. I go to the rules. You can see there are 72 rules. All of them have passed, but I purposely have some data which is failing. So you will see some rules have failed. I just want to say that the data I'm showing you today is all synthetic patients data. This is not real patients data. I just want to be very careful. So 2 rules have failed, and that's something which may be okay. My rule boundary that I set that everything has to pass. You can set a boundary that said, okay, if 90% is passing, I'm okay with that. But I said 100%. So it says you're only passing 97%. I can inspect the rules and so on and so forth. So now the glue part is done. And data steward, the first flow is done. What I'm going to do next is I'm going to go to Amazon Data Zone. And in Amazon Data Zone, I'm going to work with one of the domains. The domain concept in Data Zone is about a specific lines of business or your organization where you want to publish all of your data assets and products. So my domain is called Life Sciences. And in there, when you go to Data Zone, it's going to show you a lot of options. The option we're going to focus today is the Browse projects. And in this one, I built a project called Carcinoma Real World Data. So these are all the patients who are suffering from a specific type of cancer and their data that is listed there. So I'm going to go to this project. And as you can see, I have published some assets already. I'm going to look at those assets. One of those assets you will see is the inventory data. Now, this all I've done, under the hood, behind the scenes. But you can easily get your data from Glue to Amazon Data Zone with a click of a button. Okay? And you can see that Data Zone also adds all this metadata for using generative AI. It builds on metadata for you. But our focus today is the data quality. So as you can see, I go to the data quality tab. Within that, this is something your consumer is looking at. This is not a console experience. This is a portal experience. And in there, it's telling you that I have these 3 rules, 3 categories of rules that were executed. But my current execution is not there. So I'm going to go to data source. And I'm going to run my data source again. That data source will bring the latest information from the catalog and from Glue to Data Zone. Okay? And then this job is running. Once this job is finished, I'm going to go back to my catalog, and I'm going to see that if the new information has actually came in. So I'm going to go there, and then you can see that it shows all the sort of details, rules, and all that stuff. I'm going to go to the data. I'm going to look at the inventory data again. Data Zone also has this concept of data product. I'm going to look at all my assets. One of my assets is patients, as you know. And in the patient asset, I can basically look at the descriptions and everything else. OK, so I'm going to go and look at the patient's data. Now, this should be refreshed by now because I ran the job. and I'm going to go to the Assets tab, and I'm going to click on the patients table. Now, you can see that in this particular case, it builds all the metadata and all that stuff is great. It's going to go up to the data quality, and it's going to show you that now I have 4 categories of rule. The first one is the one I just executed. You probably noted that 72 rules were executed, and only 70 have passed. For me, it's a fail. For you, it can be passed or maybe not. So it shows you the trend over time, but we're going to also look at which rule have failed. So it gives you the full information. And then you can also find that information from the schema tab. So you can say, hey, I have all this column, which column, how many rules have executed, and of those, how many rules have failed or passed, and things like that. So with that, I'm going to go back to data quality tab. I'm going to look at the overall score. Note that also giving you category like maximum, minimum, and all those things, the row count and things like that. And it shows me pretty much all the rules. So as a consumer or as someone who's looking for data set, when I come in and look at my patient asset, it's going to show me the trend. It's going to show me all the information and things like that. Then I can also do one more thing. I can search for patient asset. So I can go up top and I can look for patient asset. And it'll give me the same information that pretty much was listed in the data quality tab. So as you have seen that with a quick, easy way, I was able to execute data quality rules against an asset using Glue. And then I brought all that information to data zone or a catalog where a consumer can look at those rules, what have passed, and then they make an informed decision of whether or not they want to use that product or not. So with that, I'm going to pass it over to Shiv to kind of go a little bit deeper into how DQ actually works and what are some of the components and features that we have just announced. Shiv?
Thank you, Navneet. Hope you're all able to hear me. So good morning again. My name is Shiv Narayanan. I'm a product manager on the Glue team. I focus on data management capabilities. I'm always flattered as to no matter what time, I've done this session multiple times, no matter what time it is, you always show up. You prioritized over the AI/ML talk, or maybe you're here by accident, I don't know. But anyway, thank you so much for making it. I greatly appreciate it. So far what you saw was how business users can actually benefit from data quality. You were able to see that you can set up from the Glue data catalog, and then you can go all the way to data zone and consume that results. But again, one of the most important thing is that Glue data quality is not just for business users, it's also for data engineers and technical team members who really want to make sure that you're doing these data quality checks way ahead in your pipelines. How many of you are data engineers? A show of hands. Oh, a large number of you are data engineers. That's amazing. So I'm going to probably convince you a little bit about why you should start using this, because my rest of the presentation is about how you can actually do this on ETL pipelines and tell you about all the new features that we launched. So first of all, I want to talk a little bit about the data quality definition language. When we created Glue data quality, one of the biggest discussions that we had in our rooms were, what is it that, how is it that, what's the experience that we're going to offer our customers to create data quality rules? And we had really evaluated 2 big options. One was we were planning to create this beautiful user interface where you can just go and click and create data quality rules. Well, that actually was something that a lot of our customers had. And one of the things that they told us was, well, the beautiful user interface is very critical, important, but they struggle with deploying that at scale across pipelines to all other places. So that was a challenge. On the other hand, we could possibly have a JSON file, a configuration file. And what our customers told was, anytime you show an open bracket and a close bracket to a business user, they just run away. So we had to kind of set, and we took a bold decision of actually creating a language called data quality definition language. And we not only did that, we also open sourced it with a hope that we'll be able to get this more adopted more broadly, write these data quality rule once, and then be able to use it across platform. And we are making quite a bit of progress this year. So a couple of things that we did this year was, of course, you can see that it's really easy to author. The important thing is we also now are supporting dynamic thresholds, as you can see in my row count greater than average of last 10 example. What that really means is that now you can actually look at your record counts over the past 10 days or any number of days, and then be able to say, you know what, at least my row count should be greater than 80% of that, right? So you can express those dynamic thresholds with data quality rules across the boards. That makes it really easy for you to maintain these data quality rules. We also very recently launched the ability for you to filter or apply where clauses in your data quality definition language, as you can see in line number 8 over there. And our team really worked hard to make line number 10 happen. It is actually ability for you to write really complex business data quality rules. As we see customers adopting, there's like crazy type of data quality rules that you guys write that we really have to now start like supporting all the nested and really deep ones. And the reason why it's really complicated is because each of those things have to be processed, and you have to kind of gather statistics and apply those. So it's really a pretty good amount of engineering work that we had to kind of undergo for that. And now I'm really glad that we now are able to do that. And a lot of our customers, no matter what type of rules we offer, they always come up with crazy creative ways of doing things. So we support custom SQL, so there's that. And we also support the ability to do data quality checks, not just on one data set, but across data sets. So referential integrity on a data lake is a very useful check. You can do that. Data set comparisons across 2 different data sets, you can do that. So I really hope that you start using this. So this is about the language, but what about the engine that's going underneath, right? So as Navneet talked about, there are multiple ways you can do data quality. One of the very common ways that we've increasingly seen is customers adopting open source data quality engines. And one of the very popular engines out there is DQ. And the history behind DQ is it actually came out of Amazon science paper that basically talks at length about how you can actually efficiently do data quality on really massive data sets. And we started using that framework initially in Amazon. It's actually used for really, really large-sized data lakes in Amazon. It really works wonderful. And then, of course, it got open source. A lot of our large customers use it on-prem. And the reason why it's able to do what it's able to do is because DQ believes in one very important principle, that it wants to take minimal number of passes at the data. So what it does is, and you'll see this over and over in the slides that are upcoming, it first passes through the data. It tries to gather statistics in as minimal number of passes. And once you gather statistics and you have that stored, you can now apply data quality checks on top of that statistics, which is much faster than applying or going one after the other rule by rule execution. So that's what DQ really, really tries to do. And our engineering team right now is kind of stewarding this, and we continue to contribute. There are other contributors as well. As if you're contributing, thank you so much. So I'm really very, very excited that we continue to improve DQ, and we have built on top of DQ, which is our open source. So next, what I'm going to do is I'm going to show you a demo like how Navneet showed you. If you're a data engineer, you want to watch this. So this is how you would actually go ahead and set up data quality checks on your ETL pipelines. So the way to kind of do this, what I'm showing you is the Glue ETL. So I'm just going to go ahead and click the ETL job. And we're going to create a visual ETL job here. Again, keep in mind, you can also do any of this in code, API, all of that. I'm going to now start with a Glue data catalog table. The catalog table is going to be a customer database. And what I'm going to do is I'm going to start an interactive session right on the studio. So this allows us to immediately view whatever is happening on the as you're processing. And as you can see, this is fake data. You have customer names. All of them is fake. And now what I'm going to do is you can obviously add any transformations that you want, and then you're going to add an evaluate data quality transform over there. So first thing what we're going to do is just to play with one rule. And what we're going to do is to create a completeness rule, making sure that the primary key on that table is going to be 100% complete, right? So it's pretty straightforward to write that. Completeness of customer SK is equal to 1. The moment you do that, on the left bottom, you will be able to see that there is immediately, you're getting that feedback of, okay, whether that rule passed or failed. And of course, as you can see here, the rule has passed. So now we're going to continue building that pipeline in Glue Studio. So what you're going to do is to see the original, like I'm just going to click a bunch of buttons, but I'm going to explain to you, I promise, what these are. So as you can see, we have now 2 additional nodes, and I'm going to click on the rule outcomes. What rule outcome is that you wrote one rule, the output of that rule is over there. And as you can see here on the very bottom, you can see the results. The row level is very, very critical for you data engineers, because what you want to do is, if you passed 1 million records, of those records, what passed, what failed, and you need a status on that, and you really need to know which rules are there. So what we do is we add 4 new columns to that data set, and then we tell you whether it passed, and then we also provide specifically which rules passed or failed. You can take this piece of information and filter and do whatever you want to do with that data set. Now, one of the important things in here is what I'm going to do now is I'm just going to go ahead and like write up all the rules that I showed you in some of the previous slides. So these are all the rules that you can write. You can write more. Some of our customers have like thousands of rules on a single data set. So it's up to you now to write all these rules. Now, what we're going to do is to go back and complete the job, and we are going to look at the script. And the reason why I wanted to show you the script is if you're a data engineer who likes to build on notebooks, you should feel free to do this. You can just write DQDL on your script and pass it to the API that we have, and it basically gives you all the results in one just API shot, right? So it's really a very simple way to do it. You can write this in code. So now the next step is we'll go ahead and run this data quality job, right? So once you run it, you will notice that the runs tab, obviously, it gets successful. And then we are going to go look at the data quality tab. Immediately, you will see a data quality score. You see all the rules that passed or failed. Of course, we don't show you the data here, but you can write the data to S3. You can set up notifications, all of that. I've run this multiple times because I want to make a very important point about the trends, right? So you can obviously see the data quality trend information. So of course, the data quality score is 57, as you can see. But if you see, there is a number of statistics gathered as 9. And the reason why it's 9 is because the rules that you've authored have gathered 9 statistics that the rule engine now runs its stats on. You can also go to individually each of these statistics and look at those statistics over time. This is incredibly helpful because now you can understand the patterns of your data. Even though it's in this demo, it's a little, it's showing you everything is 100%, but like let's say if you have ebbs and flows of it, you will be able to see all of that. So these are all some of the new things that we've actually included. Some of the common questions that we get asked is, can I access this via APIs? Yes. Can you take this, write it out, and can I query it to my heart's content? Of course, you can do all of that. So I really, really hope that you guys go back and try this, and hopefully a lot of our customers are getting much benefits out of getting the statistics view over time and also data quality over time. So what did we do after that? So of course, rule-based data quality is super important. We have launched a whole bunch of data quality rules that will be really, really helpful for you, we hope, because this is what our customers have been asking us for. So the new data quality rules are now focused on files. So some of the examples, you always want to make sure your files are recent. So we introduced file freshness. So file freshness not only works on files, it actually works on S3 folders as well. So you can set up file freshness checks. You can make sure that files are being matched. So some of the financial customers that we work with really get a checksum, and they also receive files. They want to make sure that the checksum is compared against the file. They want an easy way to do that, so we launched file match data quality rule. File uniqueness, a lot of our customers face this. They get files from their partners, but they want to make sure that the bunch of files that they receive don't have any duplicates in it. So instead of going at a data level, what we do is we can compute and figure out like if the files are unique, and then we'll be able to make sure that we tell you what percentage of the files are unique. And also you can, what we not mentioned here, but of course you can set up thresholds for all of these. For instance, 50% of my files are unique, or 80% of my files are unique. You can do those things. The last is really my favorite. The intent of that file size is obviously to make sure that you are ingesting your files of certain size. You would expect a certain size, so you can always say, you know what, it's between A or B. But I really think that how customers might be able to use this is to actually find out if your data lake has small file problems. So allowing you to make sure that you can compact based on this data quality check. Because I truly believe that even bad performance from a business perspective is also, in a certain extent, a quality issue. So you can actually start using those rules. So now we've covered rules, we've covered how it works on ETL. The most important question is rule-based data quality enough, right? And it turns out that really it's not enough. And I get inspired from some of our customers, actually one customer story very specifically, where these customers have used rule-based data quality. They set up a rule to make sure that their transaction limit, I'm just giving an example, the sum of the transaction for a given day should be, let's say, $1 million worth. Over time, and once you all know, you're data engineers, you put these data quality rules as a really very less motivation for you to go and really tweak these thresholds, right? So there's 1 million transactions. The business grew. The 1 million became $10 million. The rules were fine. They continue to pass. One day, one of the source systems forgot to send a bunch of data, and the $10 million threshold suddenly dropped to 2 million. The rules continue to pass, but there was a data quality problem that they were unable to detect. So they really wish that they were notified about the sudden drop, right? The seasonality is a classical problem. Let's say, for instance, Halloween candy sales are, low. You want to know, you ought to see that yearly seasonal patterns or the weekly seasonal patterns occur. So it's super critical that we have to combine rule-based data quality with machine learning-based capabilities like anomaly detection. And we are really, really excited to have this general availability of our anomaly detection capabilities. So this is something that you can obviously try today on Glue ETL. So the way I'm going to talk a little bit very quickly about how this works, but the benefits of this is that, as you saw, we have statistics that are gathered. We automatically apply machine learning algorithms to learn from these statistics, and then we will make sure that we are identifying the hidden insights in those, and then we alert you through observations. One of the coolest parts about this is that you can also visually see these anomalies in a very nice way, and more importantly, provide feedback to the machine learning model to make it better. And I'm going to show you how we can do that. But before that, I want to kind of level set on how this really works, right? So we all know that from the previous demo, you have data quality rules. Data quality rules generates data statistics. Then we have the rules that you've configured. You have thresholds. We look at the stats. We apply the rules, and then we create a data quality score. We tell you which records passed, failed, so that you can play with it. Now, what's going to happen is we are introducing a new concept called analyzers, right? So analyzers just tell the system that you need to gather the data statistics. And the reason why analyzers are important is, as data engineers, you may not be very interested, or you may not even know all the data quality rules. What you want to say is, look, these 5 columns are important. Just gather all the statistics for these columns and tell me something if something is going wrong. So in such instances, you want to do analyzers. Now, you can create rules for things that you know very well about your data. You can create analyzers for your data quality or things that you don't know, right? So you can combine them in the same DQDL. And what analyzers does also is just generate data statistics. They do not impact your data quality score because you're not giving any thresholds or anything to tell us. But what it does is it is very helpful for anomaly detection. I also want to stress that even if you simply write rules and turn on anomaly detection, that will also work, because end of the day, even these rules are gathering data statistics. And what happens as a result of these anomalies are you're going to get rule recommendations. These rules will help you kind of detect and future-proof your future rules. So incrementally, you can build these data quality rules. You can also provide feedback back into the ML model so that it gets better over time. So I'm going to show you how to do this. So a very familiar interface for you already, right? Like Glue Studio. So what I'm going to do is, you can see, I'm just going to the Evaluate Data Quality Transform. I'm clicking on the Anomaly Detection tab, and then I'm simply enabling anomaly detection. This is all you need to do. If you have rules, this will work. Now I want to add analyzers for this demo. I just kept it very simple. I'm just going to add a row count analyzer, and I'm also going to add a column count analyzer. You can actually, there are other analyzers like gather all statistics for all columns. If you want to go crazy for it, just go for it. But those are the 2 analyzers. I built my job out, and what I'm going to do is I'm going to go ahead and save it, and we are going to run the job. We're going to run it a few times because it needs at least 3 days worth of data, or three runs of data to learn from patterns. So as you can see here, it actually has data quality score 0 because you did not create any rules. You only had analyzers. And you have 2 statistics gathered because we gathered row counts and we gathered column values, right? So if you see here, and if you click on the statistics tab, you will be able to see both of those, and then you will be able to see a couple of things. One is how the value is trending over time. The second thing is that the value that we are predicting, right, as to how your row count is going. And then you also have the upper limits and the lower limit of the data quality scores. And now what I'm going to do is I'm going to send a data file that's really bad, as really reduced record counts, invalid columns, and immediately it'll detect 2 anomalies, and you can set up alerts for these ones. And when you look at these anomalies, you can go and click on the anomalies tab to see it. You can expand. First of all, you'll get a very clean description of what that anomaly is. You can expand into it, and immediately you can see that my reduced row count shows up there. So kind of detecting those anomalies. It'll also give you a rule recommendation that you can take and you can add them back into your data pipeline, making it really useful, making rule writing process incremental for you. So it makes it really easy. And like I said, the most important thing is that now that the anomaly, now that it has found a value, Glue will think that it is actually part of a normal operation. Yes, sure, we've detected an anomaly, but unless you tell us that it's an anomaly or not, and whether you want us to include that in your future, we wouldn't know. So one of the things you can do is select that statistic or that anomaly and then exclude from the training. So here, the model is adjusted after your feedback to make sure that it will detect the same ranges and boundaries. So this feature now gives you the ability to really combine the rule-based data quality with the anomaly detection capabilities, giving you a full-featured data quality solution for your data. And some of the reasons why our customers really love this is because of the flexibility, the ability for you to kind of run it at scale, and more importantly, putting this right in your ETL pipelines. Because remember that the most expensive operations that you will do is reading the data and writing the data. With this, what you're doing is you're putting it in your pipeline as you're aggregating your data, as you're transforming your data. You're just doing this data quality checks that actually, most of the time, your data is in the memory, making this data quality process really, really efficient. And again, like I said, combining the power of machine learning-based data quality and the rule-based data quality. So with that, what I'm going to do is to turn it over to one of our customers, Andrew Rife from Vanguard. I'm really excited for him, and he's going to show how they're using Glue data quality in their platform.
Thanks, Shiv. Good morning, everyone. It is my absolute privilege to be with you here today. I want to thank Shiv and Navneet for inviting me to speak, all of you for showing up. This is great. We have a full house. Take that, Swami. This is the real keynote. I'm joking, Swami. Please invite me back. I want to start out with a little thought experiment. So if you don't mind indulging me, just close your eyes for a second. And I want you to think about all of the data processes that run within the four walls of your organization. So I know that's a lot, so you can think about them abstractly. I want you to think about all of them in, maybe they're in HR, maybe they're in sales, marketing, maybe like Vanguard, it's investment operations. And then I want you to filter that list in your mind and figure out what percentage of those would benefit from high quality data. All right, thank you. You can open your eyes. And so what I hope you got out of that is that high quality data is really important, right? Pretty much virtually every process we run at our organizations needs high quality data. And it's foundation to pretty much everything we do. And so if we can get this right, if we can get data quality, I love this topic because it's so foundational that if we can get it right, we can do all the other stuff that we're learning about at this conference, including what Swami's talking about right now. We have a strong foundation to launch into those things. And so I think you're here because you know how important data quality is to your organization. And some of you may even know the pain of not getting it right. At best, maybe you spend hours trying to find an issue, fix it, clean up the mess it made. Or worse yet, you miss some compliance requirement, or you let some clients down. At Vanguard, we know this struggle well. Our investment systems are powered by high quality data, and the investment industry, as you can imagine, is a quagmire of regulation. So we spend a lot of energy trying to get this right. We acquire data from dozens of different market data providers. We collect data internally from our operational systems that churn it out second by second, minute by minute, and hour by hour. This data is not always clean, it's not always on time, and it's not always complete. Over the next few minutes, I'm going to share with you Vanguard's journey in data quality over this past year. I'll talk a little bit about our data ecosystem and how we structure our data. And then I will talk about how we built a custom data platform that is powered by Glue data quality. Before I do, though, by show of hands, who has heard of Vanguard and what we do, or may even be clients of ours for personal retirement savings? Okay, yeah, fair bit, great. To the clients out there, thank you for entrusting us with a big part of your future. We know financial freedom is important to you. And that's in part why data quality is so important to us. For those of you who are not familiar with Vanguard, let me give a quick intro. Vanguard is one of the world's leading investment companies. So we offer a large selection of low-cost mutual funds, ETFs advice, and other related services. We have over 50 million investors. We manage over $9.9 trillion in assets under management, and we employ over 20,000 employees, or crew, what we call them. Vanguard is a mission-driven company. The core purpose, the reason we exist, is to take a stand for all investors, to treat them fairly, and to give them their best chance of investment success. And we are relentless in our pursuit of value for our fund shareholders and our clients. And my name is Andrew Reif. It's very nice to meet you. I am the Chief Technical Advisor for our investment data systems. So let me take a step back and talk about our data ecosystem and how our data is structured, because it's important to our conversation. So at Vanguard, like many of you, I'm sure, we rely on high-quality data each and every day. And it's my department, or the department I support, that is responsible for making sure that becomes a reality. You see, we are the investment data stewards at Vanguard. We acquire all that data from third parties. We collect it internally from our operational systems. In its raw form, the data is often messy and highly nested. And it's our job, using the data systems we create, to restructure it, to standardize it, and to enrich it with important business context. From there, the data goes on to do important things like enable investment decisions, reduce risk for Vanguard, or maybe be used in analytics, machine learning, or all the other good stuff data does. We do this within a mesh-style data ecosystem in which each logical grouping of data is offered as a digital product to the rest of the enterprise. So for example, we have a digital product for our Vanguard fund valuation data, things like fund prices. We have another data product for fund performance, returns. And then we have another one for things like sanctions or currency exchange rates. In fact, my department offers over 50+ data products to the rest of the organization. Each of those data products is created and managed by a product owner, a development team, and one or more data stewards who, by the way, sit outside of IT. Collectively, it's that group that is responsible for the usability and the accessibility of the data, and of course, the quality of it as well. And each of those data products has their own definition of quality. So this is the challenge we're running up against. This is a representative data workflow that you may find within our data ecosystem. So each of those ellipses represents a different stage in the pipeline where we're doing some kind of data work. And each of the red stars indicates where we're evaluating some dimension of data quality. And so you'll notice right away that data quality is not a one-time activity, even within the context of a single pipeline like we see here. And while this pipeline, this workflow is relatively simple, they can become very complex, and they can even have dependencies on one another. So the first types of checks we do, consistency checks. Does the data conform to our expectations? Is it in the expected format? Does it have all the expected attributes? This initial validation serves really a sanity check to make sure that we're speaking the same language as the data supplier. But it really doesn't do anything to verify the accuracy or the completeness of the data. For that, we need more complex data quality controls that probe at its veracity. Is the data true according to the rest of the world? Does it match what we get from other suppliers? Does it fall within reasonable limits? This is obviously a very important dimension of data quality for Vanguard. We can't make a responsible investment decision if we think the price of a security is X, the rest of the world thinks it's Y. For these types of checks, we often use what we call reference data. So reference data it's already trusted information that we can include within our quality runs. It's used as a reference or a measuring stick to help identify inaccurate or low quality data. So for instance, we often gather the same data points from multiple suppliers, and we'll compare them. If two different suppliers don't agree on a specific data point, that's an important input for us. That's something we want to know. We also do things called variance checks, especially for data like fund prices. We take the fund price for today, we compare it against the fund price for yesterday, we call that the variance, and then we will compare that variance against some predetermined threshold. Let's say it's 10%, something well outside the standard deviation of variances we've seen in the past. If that variance exceeds the threshold, that's an indication that we might have some low quality data, and we want a data steward to take a look. But the point is these types of checks require reference data that's outside of what the supplier gives us. And so any data platform we create, any data quality engine we use needs to be able to support these kind of things. And finally, the last part is completeness and timeliness. This dimension is important. I know Shiv just talked about anomaly detection, limitations of rules-based data quality controls, and this is where it really benefits us. It's relatively straightforward for us to validate data we have within our shop, but it's another thing entirely to try to validate data we don't have. And so for Vanguard, we expect a market price for a fund or an ETF every day that ETF is trading. And so we need to know when we're not getting the full data set. So collectively, the data platform that we create and the data quality engine behind it needs to support all of these dimensions of data quality. It needs to be able to do so in a way that fits within a workflow, like you see here. And this is just one of thousands of workflows that may run every single day or month. And so we have an issue of scale too. So as I said, we were challenged this past year to really solve this data quality platform or a problem for our data systems. It was really important to us to create a federated platform that didn't define or enforce data quality in very specific ways, but instead it enabled each data system to avail high quality data in a way that's meaningful to them. They needed to be able to write their own rules. They needed to be able to run on their own schedules, execute data quality jobs on their own schedules, and they needed to be able to interpret data quality results in a way that makes sense to them. What's more, we wanted our non-technical data stewards to be part of that solution. And so we evaluated several options. We actually decided to build a custom data platform, and we wanted to power that custom data platform with AWS Glue data quality. And so I want to introduce you to G42 data platform. Again, it is powered under the hood by AWS Glue data quality, and we chose AWS Glue data quality because it gives us the scalability we need. It gives us self-service enablement for our data stewards with DQDL, and it integrates seamlessly with many of our other systems and platforms, which are also built on AWS. G42 is a collection of dozens of different microservices, databases, messaging components, queues, et cetera, all of them orchestrated to solve common data tasks for our systems, things like data management, pipeline visibility, and of course, data quality. This is a very conceptual view of the platform that really focuses on the data quality aspect and is broken into 3 layers. So the first layer we have is the interaction layer. This is the layer that the data stewards use to author rules, to assign them to workflows, and to review the data quality results. This is also where the data and control plane APIs exist that the data systems use to define and execute data quality runs. The next layer is the orchestration layer. And so with hundreds or even thousands of workflows running, we wanted to be able to scale from one data quality execution to hundreds in a very cost. Did my mic fall off? There we go. So this is the layer where the mechanisms for us to queue up and to monitor those jobs till completion exist. And then at the bottom layer is really the execution layer. This is where the magic happens. This is where we use the AWS Glue SDK, we run a Glue job, and we check the quality. This is also where we process the results, and we'll summarize it. So let's take a look at what this looks like in real time. So the very first thing that needs to happen is the data stewards, the team, the product owner, need to define what quality looks like. And they do that using DQDL within Galileo 42 data platform. They use the 20+ rules that are out of the box, and they also use custom SQL, which is a big part of our data quality success. They can define those quality rules within the interface, and then they can assign them to workflows and data domains. Then as data comes in day to day, and this could happen ad hoc, it could happen on a regular schedule every day, it could happen once a month. But as data systems receive data and they need to run quality checks, they'll stage it. And so that really means they'll put it in S3 in a way that's accessible to the platform, and they'll include reference data, any reference data that we talked about. They will include that as well, and so that the data quality execution has access to it. And then using the control plane APIs, they'll execute a request, and they'll say, I need a data quality run, and here's the location in S3. That goes through some orchestration, so it'll be queued up, we'll set up the monitors, things like that, and then it'll be executed. And so this is where the Glue ETL spins up. We actually run the rules against the data set, and we get the results. Those results are summarized by the platform, and it enriches it with some Vanguard-specific metadata that's important to our data stewards to be able to make decisions based on the results. Then using EventBridge, it'll notify the data system that it's now complete. And so the data system can pull those results, it can interpret them in a way that's meaningful to them, and it can decide, do I need to take any more action, or am I good to continue? If they choose, they can escalate. So they can notify data ops that something needs to happen. We think we have identified a data quality issue that needs to be looked at. Data ops will, again, use that interaction layer to respond. So they can go in, they can see the quarantine record, they can see the results, why it failed, and then they can progress. So the next 3 slides are screenshots of our application. And so this is really rule authoring. You can see a list of rules here that are written by data stewards, and it's enriched with some Vanguard-specific metadata, like names for the rules, data domains, and even behaviors. So what happens when this rule fails? How should the system behave? These are combined into rule sets and then assigned to workflows. This next one is pipeline visibility experience. So you can see that this is a single data feed we get from a supplier, data supplier. It's split into disparate data parts to make the data a little bit more homogeneous, which makes data quality much easier. And then you can see the bottom branch there, which is actually advisor valuation data, failed. And that's because of a quality issue. And so what happens is a notification goes out to a data ops. They come back into the system. They see it failed at this step, and then they can respond. And so here is the data quality results, the detailed results. You see a summary of the data for an execution, and then you can see failed rows, as well as the Vanguard-specific metadata. And you open those rows, and you can actually see the quality results, including the data that failed and what rules failed. So I want to close out talking through some considerations, some things that we learned that maybe we didn't expect to learn. So the first one is really about this idea of platforming. The mechanics of data quality, actually checking the quality of the data, is really only half the battle. You need to figure out how that fits into your operational processes, right? So how are people going to respond when data quality fails? How are you going to gather long-term statistics to be able to measure the quality of your data and see if new rules you're adding are actually making a difference? How are you going to build custom workflows around it? So this was a challenge for us because every organization does this differently. And so what we decided to do is really build this custom data platform around the core engine of AWS Glue, because it does data quality really well, and it does it with DQDL, which is, you can use non-technical data stewards can be part of that solution. But we had to kind of fit that within our workflows. So as you go through, maybe you do some data quality soul searching over the next year, think through that. How do ops respond to this? What are the workflows associated with data quality? What happens when it fails? Should I stop the whole pipeline? Should I just stop that record? Should I ignore it? Et cetera. Oops. The next one is dynamic data. So data is, even from a professional data supplier, is often highly nested and sometimes messy and incomplete, right? So expect that off the bat. But data changes. So we bring in a data supplier, it may have 3 different types of data sets. It is really helpful for us to split that data into its homogeneous sets. And that made rule authoring much, much cleaner for us. And so what you get is kind of this nest of workflows and multiple data quality runs. But the benefit you get is that data ops can now write relatively simple rules for the data quality because all the data is homogeneous, rather than having some data sets here where these rules apply versus the next row, which has another set of rules that apply. And so think through that is when you get a feed or the data quality that you want to run, how can you make it homogeneous? How can you look at the life cycle of the data? Where's the most appropriate place to validate the different dimensions of data quality? So that was an exercise we went through this past year. And then finally, detection burst prevention. You can detect data once it's already hit the data store, and that's certainly valuable. What we chose to do is prevent it. So we wanted to have a gatekeeper so that we knew that only high-quality data was making it into our data hubs and being distributed to the rest of the organization, because the risk of distributing low-quality data was just too high for us. And so that meant certain things that we needed to solve, like data timeliness. How do we run these data quality jobs quickly? How do we get ops to respond quickly so that we get data to our consumers as fast as possible? And so there's some challenges around there. But you'll, as well, have to think through, do I want to detect data quality after it's already in my data store? Or do I want to prevent it from getting there, which implies some kind of pipeline work? So on behalf of Shiv, Navneet, and I want to thank you for showing up today. There is a survey in the app. Please, please, please take some time to go through that. It means a lot to us. And we're going to hang out up front. If you have any questions, you want to talk through the solution, we're going to be here. So thank you very much.